What's up everybody, this is Teacher Ivan from NextGen Academy. Our goal in this channel is to help you achieve your highest potential and to help you understand subjects in the easiest and the most efficient way. If you'd like to get more tips and tricks on how to achieve A star in your IGCSE, don't forget to like, comment, share and subscribe to this channel. Lastly, if you need any help in your studies, you can always head on to our website, link in the below, or our Instagram, drop us a DM and we'll be able to help you. Enjoy this video and I wish you all the best.
All right, okay, welcome back, my NextGen family. Okay, today we are going to go through the February-March 2025 paper 1 for AdMath. Okay, this is the first official non-calculator paper from the 2025 series onwards. Okay, so put your calculator aside. Okay, the instructions are still the same. Make sure you all do this without a calculator. Okay, so the formulas I would say is about the same, just that there are some extra formulas that they have given us, which is circles, okay, some shapes formula here, and the rest is about the same as the previous ones. Okay, that's the previous exam paper. Okay, let's jump straight into question number 1A. On this axis, sketch the graph of 4 modulus x minus 1 and y equals to modulus 3x plus 2, stating the intercepts with the axis. Okay, both of these, they are, okay, what are they? Okay, they are modulus graph. Okay, how can we find a modulus graph? Okay, let's look at the first one. 4 modulus x minus 1. Okay, 4 modulus x minus 1. What do we do for this? Okay, what do we do for this type of question? Okay, so we have to understand that a modulus graph will give us like a V shape like that. Okay, it's from a straight line. Then after that, it's being reflected up. Okay, reflected up, so it becomes like a V shape. Okay, we need to find where are the x-intercept and where is the y-intercept. Okay, how to find x-intercept and y-intercept? Let's start with the first one. Okay, I'll do the working at the bottom here. So y equals to 4 modulus x minus 1. Okay, shape, both of them are V shape. So the first one, okay, what do we do for the first one? Okay, we can start off with this. Okay, it's going up. The original graph is going up like this. So we can do x-intercept. Y is equals to 0. Okay, so 0 equals to 4 modulus x minus 1. Okay, then this one will be 0 equals to modulus x minus 1. Okay, this one won't affect our plus and minus. X minus 1. We will have x minus 1 equals to 0. Then x is equals to 1. Okay, so this one won't really affect. Okay, the y-intercept. Okay, how do we find the y-intercept? Y-intercept is when x equals to 0. So y equals to 4 modulus 0 minus 1. This one will be 4 modulus minus 1. 4 times positive 1, which is equals to 4. Okay, but this is one thing that we need to know. When we do this type of question, we have to know what is the original graph first. Okay, how it looks like. So this original one, if without the modulus, is actually negative 4. Okay, so this is the original one, going up like that. So x equals to 1 here, then originally it's negative 4. So because it's 4 times negative 1. Then when it's reflected up, that's why it becomes positive 4. Okay, so we have to be aware on this original shape first. Okay, the second one, y equals to 3x plus 2. Okay, this one same thing also. Okay, how do we calculate this? We need to find our x-intercept. We need to find our y-intercept. Okay, what is the x-intercept? X-intercept, y equals to 0. So 0 equals to 3x plus 2. Okay, actually we don't have to put the plus minus because we'll be with 0 anyway. So here will be negative 2, 3x, x equals to negative 2 over 3. Okay, the y-intercept, x is equals to 0. So y equals to 2. Okay, so this one, 0, 2. So we try our best to draw it to scale as much as we can. When you all measure it, you all use your ruler. Okay, so maybe like 1 cm or 1.5 cm, you have to set a certain scale. So let's say if here is 1, okay, we set here 1, negative, then positive 4. So 1, 2, 3, 4. Okay, this is what we want. Like this. Like this. Okay, it needs to be in the same angle. Like that. Okay, then negative 2 over 3. Okay, this here is 1, negative 2 over 3 around here. Negative 2 over 3, then 2. Okay, so something like that. Okay. This one, we actually need to show the intersect twice. Okay, so we may need to modify this a little bit because we need to show the intersect twice. Okay, I think too high already. Let me... Wait. Oh, yeah. Okay, I will modify a little bit. You'll see here. This is what I'll do. So this part here, we slant down a little bit. Negative 2 over 3. This one 2, 3, 4. Okay, like this. We need to show 2 points of intersection. All right. Okay, so what else we need to take note of? Yeah, just like that lah. Okay, the gradient of this one needs to be steeper because this one is 4x. Okay, the next one, solve the inequality. When we got modulus at both sides, we square both sides, okay, to solve this. So square this 4x minus 1 bracket square less than equal 3x plus 2 square. Okay, try not to do the plus minus over here. Okay, so here will be 16x square minus 2x plus 1 less than or equal 9x square plus 12x plus 4. Open up the left hand side, 16x square minus 32x plus 16 less than or equal 9x square plus 12x plus 4. Okay, shift everything to the left hand side. 7x square minus 44x plus 12 less than or equals to 0. Then we factorize this. 7x minus 2x minus 6 less than or equals to 0. X is equals to 2 over 7. X is equals to 6. This is a quadratic inequality. So less than means like this. Okay, this is a quadratic. Then you put the two roots, 2 over 7 and 6. So your final answer will be in between 2 over 7 and 6. This is the final answer. All right. Okay, number 1. If you can do this, can you type 1? This is a straight line graph with inequality. Okay, 1, 1, 1. All right. Okay, let's move on to question number 2. Okay, number 2. The diagram shows the curve y equals to a cos bx plus c for negative 180 to 180 degrees. It is given that a, b, and c are integers. Find the value of a, b, and c. Okay, so we first have to understand what is a, b, and c. A is amplitude. Amplitude means from the middle to the highest or the lowest point. B means period. Period also can mean in 360 degrees, how many cycles are there? Okay, how many cycles of the cos graph are there? Then C is the vertical translation, whether shift up or shift down. The first thing that we're going to do here is we find where is the center line first. Okay, draw the center line, the new center line based on this. We've got 3 and minus 7. Okay, where is the center line between 3 and minus 7? You take 3 plus minus 7, which is minus 4. Minus 4 divided by 2 will be minus 2. So this is the center line. Okay, y equals to negative 2. Okay, why we start from here? We can find the a value first. Okay, a is from here to here. the center to the highest or the lowest point. So we can say that A is 3 minus 2, which is equals to 5. You don't have to write the working. This one, you just write the answer also, is fine. Okay, B is period. Period, we also can see another thing. Okay, because this one, the period, not so nice, right? Normally we'll use B equals to 360 degrees divided by B, right? Another way that we can see it is like this. You see, this is 360 degrees. See? Negative 180 to 180 is 360 degrees. So within 360 degrees, how many cycles of cos graph is there? So this is an upside down cross graph. You see, here is 1 cycle, 2 cycles, then 3 cycle. Okay, so we can say that the B is equals to 3. Okay, another way that we can understand this is in 360 degrees, there's 3 complete cycles. Okay, then the last one, C is vertical translation going down. Okay, so C is equals to -2. All right, so trigonometry graph is pretty simple. They give you the graph, they ask you to find A, B, and C. Okay, number 3. Okay, number 3, this is a new topic. The point A has coordinates -3, 6. The point B has coordinates 7, -8. Given that the line AB is the diameter of a circle, find the equation of the circle. Okay, let's do a rough sketch here first. We have a circle. We have A and B. Okay, let's say that probably it's something like this. Okay, A is here, -3, 6. B is 7, -8. Okay, they want us to find, they say AB is the diameter of a circle. Find the equation of the circle. Okay, what is the equation of the circle? We can find the formula over here. Equation of the circle. X minus A bracket square plus Y minus B bracket square equals to R square, where A and B is the radius, is the center, and then radius is equals to R. Okay, so we write down the formula first. X minus A square plus Y minus B square equals to R square. All right. So what do we need to find? Okay, we can find what is this A and B first. Okay, this little A and B is the center of AB. Okay, the midpoint of AB. So let's find what is the midpoint of AB first. Midpoint of AB, which is equals to -3 plus 7 divided by 2, 6 minus 8 divided by 2, which will get -3 plus 7, which is 4, 4 over 2, which is 2, 6 minus 8, minus 2, divided by 2, minus 1. So the center here is 2, -1. Okay, we've got A and B already. Now we need to find what is this R or R square. Okay, how can we find R square or the value of R? We can find the distance between AC or CB. Okay, either one of it, AC or CB. We use length formula. Okay, what is the length formula? Length is square root, or we can say it's length square equals to x2 minus x1 square plus y2 minus y1 square. Okay, why I leave it as length square? Because the formula, we want radius square. So we just leave it in radius square. Length is the radius. So radius square, okay, equals to x2 minus x1. So 2 minus minus 3. Let's take the A and C here. Okay, we take length of AC. So here will be 2 minus minus 3 square plus -1 minus 6 square. Okay, this will be 5 square plus -7 square, 25 plus 49. 25 plus 49 is equals to 74. Okay, then we fit all of this. Okay, this is your A and B. This is the R square. We fit into the x minus A square plus Y minus B square equals to R square. The final answer will be x minus 2 square plus Y plus 1 square equals to 74. Okay, this is your equation of circle. All right. Okay, number 3. Okay, circle one. Hopefully not so hard question come out for the official exam that is coming out soon. All right. Okay, number 3 done. Let's go to number 4. Okay, number 4. The polynomial p is given by px equals to a square x cubed plus 2a square plus ax plus 2, where a is a positive integer. It is given that 2x plus 1 is a factor of px. Find the value of a. Okay, this is under the chapter of factors and polynomials. Okay, first of all, what does it mean is a factor? Okay, if they say it is a factor, means when we substitute into the px equation, we can use factor theorem is equals to 0. Okay, the x value will be equals to 0. So we can say that when we sub in this one, 2x plus 1 equals to 0, x equals to negative 1 over 2, p negative 1 over 2 will be equals to 0. Okay, this is according to factor theorem. Okay, now let's sub in x equals to negative 1 over 2. A squared negative 1 over 2 cubed plus 2a negative 1 over 2 square plus a negative 1 over 2 plus 2 equals to 0. Okay, let's simplify this. Here will be negative 1 over 8a square plus, okay, this will be 2a times negative 1 over 4. Positive 1 over 4. So 2a times positive 1 over 4 will be 1 over 2a minus 1 over 2a plus 2 equals to 0. Okay, plus 1 over 2 minus 1 over 2 will cancel off. So it will be negative 1 over 8a square plus 2 equals to 0. Okay, we can do as 1 over 8a square equals to 2. A square is equals to 16. A supposedly plus minus 16, but they only want the positive integer, so plus 4. Okay, positive 4. This will be our a value. Okay, then they say hence factorize px. Now we have, isn't it negative 2? Yeah, no, you move it around. This one I move over here. So it's positive 1 over 8a square. Okay, by right, it's the other way around. Then equals to 2. Okay, now we factorize it. So we will substitute in the a equals to 4. So px will be equals to 16x cubed plus 8x squared plus 4x plus 2. Okay, we are going to divide it. Okay, we're going to do long division. So 16x cubed plus 8x squared plus 4x plus 2. We divide this by, okay, the factor was 2x plus 1. So we're going to divide by 2x plus 1. Here will be 8x squared, 16x cubed plus 8x squared. Okay, normally what I would like to do, you put a minus here. So all these minus, this one will become 0. So 0x squared plus 4x. Okay, you can just write as 0x. So here will be 0x squared plus 0x and 4x plus 2. The last one will be plus 2, which is 4x plus 2. So the final answer here will be 2x plus 1, 8x squared plus 2. Okay, here, because they asked us to factorize, so 8x squared plus 2 cannot factorize. Okay, but we only can factorize a highest common factor. There's no like bracket anymore. So this part, you can write it as 2x plus 1, then 4x squared plus 1. Okay, so you factorize 2 from here. Because this one, you can't do a quadratic factorizing. 2x plus 1, 4x squared plus 1. Okay, then they say here, hence show that the equation px equals to 0 only has one root. Okay, so if px equals to 0, how do we solve for root? We take the bracket equals 0, bracket equals 0. Okay, so there are two ways to prove this. You can either do like this, 2x plus 1 equals to 0, x equals to negative 1 over 2. 4x squared plus 1 equals to 0. X squared equals to negative 1 over 4. You can write here, no real root or no solution. Okay, then we can say, therefore, one solution. Or another way to prove it, you use b squared minus 4ac for this part here. Okay, this is typically what the mark scheme will write. So b square is 0 square minus 4ac, which is equals to -4. -4 is less than 0. Therefore, we can say no real roots. Then we can say 1 real root. This is the only root over here. Okay, number 4. If you can do this, then you type 4. Factors and polynomials. Okay, so most likely factors and polynomials will come out for paper 1. Because even based on the previous syllabus paper, this one normally they say do not use a calculator to do it. Okay, so this one please practice with mental calculation when you all do your past year papers. Okay, number 5. Write 2x squared minus 2x plus 3 in the form a bracket x plus b bracket square plus c, where a, b, and c are constant. This is completing the square form. Okay, so we have to do CTS for 2x squared minus 2x plus 3. First thing I'm going to do is I'm going to factorize 2 from a and b. Okay, 2 bracket x squared minus x plus 3. Then we apply CTS. Here will be x minus 1 over 2 square minus 1 over 2 square plus 3. Okay, why I write it like this? Because I only want to focus on this. Okay, the formula is this. If you are not clear, is x square plus bx, x plus b over 2 square minus b over 2 square. Okay, this is the only step that you need to do. The others all just follow only. Okay, let's simplify it. This will be 2x minus 1 over 2 square minus 1 over 4 plus 3. 2 bracket x minus 1 over 2 square minus 1 over 2 plus 3. And our final answer will be x minus 1 over 2 square minus 1 over 2 plus 3. Plus 3 means 6 over 2. So plus 5 over 2. Okay, next one. It is given that fx equals to 2x squared minus 2x plus 3 for x less than or equals to p. Okay, this part here is very important. Why did they say this? Write down the greatest value of p for which f has an inverse. Okay, this is what we need to remember. When they say that they want a quadratic to have an inverse, what does it mean? Okay, this is a happy face graph. So your happy face graph, they ask you to find CTS is because they want us to find the maximum or minimum point first. Okay, the minimum point is over here. 1 over 2, 5 over 2. Okay, originally, this is a many to one relationship. Okay, many to one. A many to one relationship don't have an inverse because the inverse of it is 1 to many, which is not a function. So we need to change a many to one to a 1 to one relationship. Okay, so for f inverse to exist, we need to make it to a 1 to one relationship. So how to make it to 1 to one? You're going to split this into half. You either take the left-hand side or the right-hand side depending on the domain that they give you. So they say x is less than or equals to p. So they want the less than part. Means this part over here, they don't want. Okay, we only take the left-hand side part because this is a 1 to one function. And what is the x value? You take the minimum point x. So the domain right now is x less than or equals to 1 over 2. Okay, so p is equals to 1 over 2. Okay, then you look at this one. Using this value of p, write down the range of f. Range means your y value. So this one is everything above 5 over 2. So we'll take as fx, or we can just write as f more than or equals 5 over 2. Okay, if you write it as y, normally they will accept it also. Okay, fx, y is all the same meaning. Okay, now using this value of p, find an expression of f inverse. Okay, so find your inverse function. So I will start with this statement. Let y equals to f inverse x. Fy is equals to x. Okay, what is fy? We can take this. Okay, we can use the CTS one. Will be easier for us to do the inverse function. So we will take 2 bracket y minus 1 over 2 square plus 5 over 2 equals to x. Okay, we rearrange everything. 2 bracket minus 1 over 2 square, x minus 5 over 2, y minus 1 over 2 square. This is 1 over 2, x minus 5 over 2, y minus 1 over 2. This will be plus minus square root 1 over 2, x minus 5 over 2. If you want to open out the bracket, also it's fine. Okay, but not necessary. Then y equals to half plus minus square root 1 over 2, x minus 5 over 2. Okay, every time when we do function, we have to look at the domain and range. Okay, what is the range for this f inverse x? What do you think is the range of f inverse x? So we need to look back at what we did over here. We only calculated the domain and range for fx. So we have to understand this. When we do inverse, domain will become range, range will become domain, because all the x will change with y and all the y will change with x. Okay, so what is the range for f inverse x? Let's write this down first. Range of f inverse x will be less than or equals to 1 over 2. Okay, why? Because it will follow the domain of the fx graph, the x of the fx graph. Okay, so we have to know this one. Same as domain of fx. Okay, why is this important? Because our final answer, okay, our final answer here, we cannot put it as plus minus. We only can put as minus. Because if we put plus, the value will be more than 1 over 2. Over here, our range is supposed to be less than or equals to 1 over 2. So we will only accept the negative one. Since here, half minus something will be something smaller than half. If half plus something, it will be something more than half. So we have to reject the positive one. Okay, so sometimes it's positive, sometimes it's negative. We have to look at this over here. So key thing over here is to remember that domain will become range, range will become domain. So check when you all show your final answer, especially when got plus or minus. All right, okay, number 5, all good. Okay, let's move on to number 6. Okay, number 6 is on trigo. Okay, trigo, this one is one of the interesting way to ask the question. Last time, we don't have to worry about this one because we can use calculator, but now we have to derive it, okay, using trigonometric ratio. Trigo ratio means your soka tua. So now they give you, it is given that tangent theta equals to sec 5 over 5 and the theta is from 180 to 360. Okay, what does it mean? 180 to 360, and then this tangent is positive right now. Okay, so we first thing that we need to determine is where exactly is this tangent value at? Which quadrant is it at? According to ASTC, the only one that is tangent positive is quadrant 1 and quadrant 3. Right? Okay, this is our, okay, they say theta, so we put theta here, theta here. Okay? Either quadrant 1 or quadrant 3, but they say this is within 180 to 360. So we only want the bottom part here. Okay, so on the top, we don't want. So which quadrant is it at? The only possible one is at quadrant 3. We first have to know this. Why is it important to determine that this is at quadrant 3? Okay, because the theta here, okay, so tangent is toa. Okay, soka toa. Opposite over adjacent, which means this is 5 and sec 5. Okay, 5 and sec 5. So when we draw this out, okay, let me just draw it clearer from here. This is from your quadrant 3. Okay, our theta is over here. Sec 5 and 5. Okay, later when we do the soka tua, only tangent is positive here. Sine and cos will be negative over here. Okay, so let's use Pythagoras theorem to find the hypotenuse first. Okay, let's call this H. So using Pythagoras theorem, we will take H square equals to 5 square plus cert 5 square. Okay, what's cert 5 square? This is 25 plus 5, which is equals to 30. H is equals to cert 30. Okay, H is equals to cert 30. Then K is adjacent over hypotenuse. Wait, hold on a minute. So Katoa. Did I do something wrong here? Opposite. Oh, sorry. Teacher did wrong already. Okay, here supposed to be the other way around. Cert 5 and 5. Okay, so you see, I have to double check. So this is cert 5. This one is 5. Okay, but the hypotenuse will still be the same value. Okay, so K. Okay, K will be 5 over cert 30. Okay, but we have to put a negative because cos, okay, here, cos and sine is negative here, okay, in the third quadrant. So cos theta is equals to 5 over 30. Negative. Okay, we need to rationalize the denominator if possible. So like this question, I'm going to rationalize it. Cert 30 times cert 30 negative 5 cert 30 over 30, which will be equals to negative cert 30 over 6. Okay, to be safe, you all just rationalize whenever the denominator has a cert. Okay, then the next one, sine theta. So we follow this again. So cert 5 over cert 30, then negative. So sine theta is negative cert 5 over cert 30. Using our law of certs, we can join both of it together like that. Cert 5 over cert 30, which will become cert 1 over 6. So 1, we can write like that. 1 over cert 6. Then we rationalize this times cert 6 times cert 6. This will be equals to negative cert 6 over 6. Okay, the next one. Now we got sine, cos, and tangent already. Find the value of secant theta plus cot theta, giving your answer in the form A plus B cert C over cert 5. Okay, so sec theta plus cot theta, which is equals to 1 over cos theta plus 1 over tangent theta. Okay, where is the cos? Cos is the negative cert 30 over 6. So we can inverse it. This will be negative 6 over cert 30. Tangent, okay, going back to the question, is cert 5 over 5. So now it becomes 5 over cert 5. Okay, we inverse both of it. Okay, we only want at the bottom to have cert 5. Okay, so the cert 30, how can you change the cert 30 to just cert 5? We can make it to cert 6 times cert 5. Okay, because cert 6 times 5 will be 30. Okay, from here, we don't want the cert 6 at the bottom, so we're going to rationalize here. This one also be times cert 6 times cert 6. This will be minus 6 cert 6 over 6 cert 5 plus 5 cert 5. The 6 and 6 will cancel off. Okay, this one cancel off. And we'll get 5 minus cert 6 over cert 5. Okay, so for those of you who say that teacher, indices and certs is not in math anymore, okay, so do I still need to study? Yes, you need to master it. Okay, they assume that you all already know this chapter. Okay, because this is what you all learn from mathematics. They will ask you questions like this. For tomorrow's exam also, okay, for those of you who are doing mathematics IGCSE paper, make sure you all know how to master your certs. I'll predict it'll come out in the non-calculator paper. All right, so okay, question 6, we are done. Let's move on to question 7. The diagram shows part of the curve y equals to 5 over x plus 1 plus 2 and part of the line y equals to 2x plus 1 intersecting at point A. Find the coordinates of A. 4-mark question. Okay, where they intersect, this one we'll do a simultaneous equation. Okay, so we just equate both of it with each other. So 5 over x plus 1 plus 2 equals to 2x plus 1. Okay, we're going to bring the plus 2 to the right hand side. So this will become 2x minus 1. We bring x plus 1, multiply with the top, 2x minus 1, x plus 1, which will get 2x squared plus 2x minus x minus 1. Okay, we shift everything to one side. Let's shift everything to the right hand side. This will become 2x squared minus x. Is it minus x? Minus 8. Hold on a minute. 2x squared. 2x squared plus 2x minus x minus 1. It should be plus x, right? How can I get minus x if I'm working? Let me see. Plus x minus 6. Okay, this correct? Okay, let me just double check. 2x and x. Okay, 3 and 2. Plus 2 minus 3. Okay, yeah, right. Okay. So 2x minus 3, x plus 2 equals to 0. X is equals to 3 over 2. X is equals to negative 2. Okay, so according to the value given or based on the graph, x cannot be negative. So we will only take x equals to 3 over 2. Okay, this one, we don't care. Reject. Okay, reject this one. So x equals to 3 over 2. Now we want to find the y value. We substitute into y equals to 2x plus 1. So y equals to 2x plus 1. This will be 3 plus 1, which is equals to 4. Therefore, our A coordinate is 3 over 2, 4. Okay, let's go to the next one. Find the exact area of the shaded region. Okay, let's go back to the graph. This point here is 3 over 2, 4. Okay, to find the exact shaded region, we will take the area under the graph from here to here. Okay, so from 0 to 3 over 2 minus this part here. Okay, if you want to find an area like this, you can just take the equation of the top of the graph minus the equation at the bottom of the graph, then you just integrate it. Okay, so you can take 5 over x plus 1 plus 2 minus 2x plus 1. Okay, minus 2x plus 1 to find the area. Okay, let's see. Let me just do here. Oh, sorry. Actually, you can do area of trapezium as well. Okay, we keep it simple. Let us do 5 over x plus 1 plus 2 first. Okay, so I will take area of this minus area of this trapezium. Okay, let's do the working here. Integrate. Okay, let's integrate 5 over x plus 1 plus 2 dx from 0 to 3 over 2. Okay, what will we get? When we integrate this one, we'll get 5 ln x plus 1 plus 2x from 0 to 3 over 2. Okay, we substitute inside 5 ln, okay, 3 over 2 plus 1. 3 over 2 plus 1 will be 5 over 2 plus 2 times 3 over 2, which is 3. Minus 5 ln 1 plus 0. Okay, ln 1 and 0, this one will become 0. So this will just become 5 ln 5 over 2 plus 3. Okay, this is area under the curve. Okay, area under curve. Now the area of trapezium. Okay, what is the area of the trapezium? 2x plus 1. Okay, this part here, this is equals to 1 because this is the y-intercept. So we can use trapezium. This is 1. This is equals to 4. Then the height is equals to 3 over 2. Okay, this is A. This is B. So we'll use the formula 1 over 2 A plus B times height. A plus B is 1 plus 4 times 3 over 2. So 1 over 2 times 5 times 3 over 2. This will be 15 over 4. Okay, 15 over 4. So the last part here, we will take area under the graph minus area of trapezium. Okay, so area of shaded will be equals to 5 ln 5 over 2 plus 3 minus 15 over 4. Okay, 3 minus 15 over 4. 3 times 4 is 12. 12 minus 15 is minus 3. Okay, so here will become 5 ln 5 over 2 minus 3 over 4. Oops. Okay, this is number 7. Okay, we're going to go to the fun one. Okay, let's go to question number 8. Okay, number 8. The first term of a geometric progression is 10. The geometric progression has a positive common ratio r. The first term of an arithmetic is also 10. The arithmetic has a negative common difference of d. So this is minus d. The second term of the geometric progression is the same as the fourth term of the arithmetic progression. The third term of the geometric is the same as the sixth term of the arithmetic. Find the value of r and d. Okay, let's write down what are the information here first. Okay, they give us geometric progression. Okay, let's write it as GP. The geometric progression, the A is equals to 10. The R is equals to R. Right? Okay, this is the first thing. The arithmetic progression, okay, right here, the arithmetic progression, A is equals to 10. The D is equals to negative D. Okay, the common difference is negative D. Okay, the next part here is they say the second term and the fourth term. Okay, so we are all referring to term. You can go to your formula sheet. You write down the formula of arithmetic and geometric progression first. Okay, it's given over here. We'll be using these two formula. Un here is the term, the nth term, a plus n minus 1d and ar to the power of n minus 1. Okay, so this one, the formula is un ar to the power of n minus 1. The nth term for here is a plus n minus 1 d. Okay, the first statement is second term of this. So that means u2 of GP is equals to fourth term of AP. Okay, meaning when n is equals to 2, that means this will be AR 2 minus 1, AR1. This will be 10R is equals to A plus n minus 1D. This one is also 10 plus 3 negative D. Okay, the D is negative over here. So 10R equals to 10 minus 3D. Okay, so we leave it here first. We give a bit of space because this one we'll need to do a simultaneous equation. The second one is the third term of the geometric progression is equals to the sixth term of the arithmetic progression. So we'll take here as 10R squared equals to 10 plus 5 negative D. Okay, so here we come 10R squared equals to 10 minus 5D. Okay, 10 minus 5D. So we want to do a simultaneous equation between both of it. Okay, let's see what can we get rid. Okay, let's try to do an elimination here. Let's get rid of the D. Okay, so I want to multiply this by 3. Multiply this by 5 and multiply this by 3. Okay, let's call this equation 1. Yeah, right at the side here. So we'll take this one equation 2. Okay, equation 1 we multiply it by let me see, do we need to multiply 15? Okay, yeah. So equation 1 we multiply by 5. Equation 2 we multiply by 3 because we want to eliminate the D value. This will be 50R. Okay, 50R equals to 50 minus 15D. Then here will be 30R squared equals to 30 minus 15D. Okay, let's call this equation 3 and equation 4. Okay, we are going to subtract this one. So we'll take equation 3 minus equation 4. This will be 50R minus 30R squared equals to 20. We shift everything to the right hand side. 30R squared minus 50R plus 20. Okay, then we divide everything by 10. This one divide by 10. This will be 3R squared minus 5R plus 2 equals to 0. Okay, then we solve this. 3R squared. Okay, let's bring it up over here. Okay, so 3R squared minus 5R plus 2, we factorize this. This will be 3R and R. 3R and R, this will be 3R minus 2, and then minus 1 here. R is 2 over 3. R equals to 1. Okay, R common ratio cannot be 1. Okay, because in a geometric progression, if your value is 1, then you keep multiplying by 1, multiply 1, multiply 1. Okay, so R cannot be 1. So this one we have to reject it. It needs to be any value other than 1 or 0. Okay, after we get this R already, now we have to find what is D. Okay, let's see which equation substitute the R inside will be the easiest. Okay, I would choose equation 1 here. So let's substitute R equals to 2 over 3 into equation 1. 10 times 2 over 3 equals to 10 minus 3D. This will be 20 over 3 equals to 10 minus 3D. 3D equals to 10 minus 20 over 3. Okay, this one will be 30 minus 20. So 10 over 3, 3D. D will be equals to 10 over 9. Okay, so keep on practicing your mental calculation. You see there's a lot of fraction type of equation to make silly mistakes. D is 10 over 9. Okay, the next one. Determine whether the geometric progression has a sum to infinity. Okay, what is the condition of sum to infinity? You all see in the formula, okay, they actually gave us this. What is sum to infinity? The condition is modulus R must be less than 1. Okay, what does this mean? Modulus R must be less than 1. Okay, we can do this. Modulus R less than 1. R needs to be in between -1 and 1. Okay, so your condition, if R is in between -1 and 1, then it has a sum to infinity. Okay, so we can say that R is equals to 2 over 3, which is, okay, which is in between -1 and 1. Then we can say it has sum to infinity. Okay, so we just need to see the value. As long as in between -1 to +1. Okay, so this is on progression. Let's move on to question 9. Okay, number 9. Solve the equation log 2x plus 1 minus 4 log x plus 1, 2 equals to 3. Okay, this is on logarithm. When we have different base, we have to change it to the same base first. Okay, we have to change it to the same base. So which base you want to change it to? Up to you. Okay, you want to change it to log 2 or log x plus 1? Entirely up to you. Okay, for me, I want to change it to log 2. Okay, so we change this here. Okay, this one. Log 2 over log 2x plus 1, which is equals to 3. Okay, if you know the shortcut method, you can straight away just write 1 over log 2x plus 1. So this will become log 2x plus 1 minus 4 over log 2x plus 1 equals to 3. Okay, to simplify this, we let u equals to log 2x plus 1. Okay, so that we can make it to a quadratic equation. We have to recognize log, ln, exponential normally will have some sort of quadratic equation like this. So u minus 4 over u equals to 3. We multiply the whole thing by u, so this one become u square minus 4 equals to 3u. U square minus 3u minus 4 equals to 0. And we'll get u minus 4, u plus 1 equals to 0. U is equals to 4, u is equals to -1. Okay, let's solve for both of these. We change the u back to log 2x plus 1 to solve for x. Log 2x plus 1 equals to -1. Okay, this one we're going to change log form to index form. So x plus 1 equals to 2 to the power of 4. 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. X is equals to 16 minus 1, which is 15. And the next one here, x plus 1 is equals to 2 to the power of -1. This is 1 over 2. Therefore, x is 1 over 2 minus 1, which is minus 1 over 2. Okay, can x be minus 1 over 2? We look back into this question. Can x be -1 over 2? Okay, so we know that the condition of log and ln, our entire argument cannot, or base cannot be negative. But here right now is negative. Okay, but you see, right, when we substitute back into here, it doesn't give us a negative. It is still a positive value. So you don't go and reject this one. Okay, so it's not always when you get an x is negative for a logarithm type of question, you have to reject it. You have to substitute it back to the equation to see whether it's still a positive value or not. Unless it makes it to become a negative value, then only you have to reject it. Okay? All right. Okay, let's go to question number 10. Okay, I'll go through the whole thing together. Okay, let's go to number 10. Okay, point P lies on the curve y equals to 5x plus 2 to the power of 2 over 3. The x coordinates of P is 5. The normal to the curve at P intersects the line x plus y equals to 1 at the point Q. The point R is a reflection of Q in the tangent to the curve at P. Find the coordinates of R. Okay, to visualize this, let's try to do a rough sketch on this this whole curve and normal line and tangent line. Then we can see where exactly is the P and Q and all these are. Okay, we have a curve. Okay, we don't know how the curve looks like, but let's do a rough sketch. Maybe like that. Okay, this is a curve. Some sort of curve. Okay, the point P lies on the curve. Where's the point P? Okay, let's assume P is here. Okay, P, we know x is 5. Okay, we don't know what is the y value, so we need to go and find the y. The normal to the curve at P. Okay, normal means we've got this one. Okay, let's say this is your tangent. Your normal will be this. Okay, the normal to the curve at P intersects at the line x plus y equals to 11. Okay, so x plus y equals to 11 is some sort of line. Okay, we don't know where is it, but got some sort of line at the point Q. Okay, maybe Q is around here. Okay, let's just assume Q is around here. Okay, and it intersect with this x plus y equals to 11. Then the point R is the reflection of Q in the tangent to the curve P. Okay, so this one just now we said this is the tangent. This one is the normal, right? So can we assume that R probably is here? Okay, because according to the story, they say point R is the reflection of Q in the tangent. So reflection means the distance here and the distance here is exactly the same. Okay, this distance and this distance is exactly the same to get to R. Okay, so try to draw it out first so it's easier for us to understand this. Okay, let's start by finding what is point P. Okay, point P is, we substitute x equals to 5 into the y coordinate, y equation. So y is equals to 5x plus 2 to the power of 2 over 3. Okay, at x equals to 5. So y equals to 5 times 5 plus 2 to the power of 2 over 3. 25, this one will be 27 to the power of 2 over 3. Okay, always simplify it first. So we do this 27 to the power of 1 over 3 squared. Cube root 27 is equals to 3. So 3 square, this is 9. So the point P is equals to 5, 9. Okay, 5, 9. Let's put into the graph here. Okay, the next thing, now we want to find, they say the equation, the point Q is on the equation of the normal and it intersects the line at x plus y equals to 11. Okay, so this one is the normal line. Okay, equation of normal and it intersect here at x plus y equals to 11. So the next thing that we're going to find right now is what is our equation of normal. Okay, let's do over here. Okay, equation of normal. Okay, we need to find what is the dy over dx first. So dy over dx, we're going to differentiate this 5x plus 2. So this will become 2 over 3. We do a chain rule, 5x plus 2 to the power of negative 1 over 3 multiplied by 5. This will become 10 over 3, 5x plus 2 to the power of negative 1 over 3. Okay, equation of the normal, this will be, we substitute x equals to 5. Okay, x equals to 5. Dy over dx is 10 over 3, 25 plus 2 to the power of negative 1 over 3. Okay. Plus 2, not 7. Okay, so this is 27 to the power of negative 1 over 3. Okay, remember just now 27, cube root is 3, power negative 1 is 1 over 3. Okay, so here is 10 over 3 multiply 1 over 3, which will get 10 over 9. Okay, so the gradient of the tangent is 10 over 9. Okay, we can say that the gradient of tangent is 10 over 9. Okay, you can write this down. The gradient of normal will be negative 9 over 10. Okay, how do we find the equation of normal? Right now, we want to find equation of normal. We have gradient, which is negative 9 over 10. We got the p value, so it intersects at p. So gradient of normal is negative 9 over 10. P is 5, 9. Okay, these two are the values that we want to use. And we're going to substitute into y minus y1 equals to mx minus x1. This is to find the equation of normal. So y minus 9 equals to negative 9 over 10 x minus 5. Okay, this is equation of normal. You want to simplify it to y equals mx plus c also can, or you want to leave it like this also can. Okay, let's simplify lah. Negative 9 over 10x plus 9 over 2. Okay, bring the 9 to the right hand side. We plus 9. So 9 plus 18 is 27. So 27 over 2. Okay, not necessary to do this. Okay, so this is our equation of normal. Okay, equation of normal intersects x plus y equals to 11. Okay, so intersects. Okay, this one intersect this graph. Since this one intersect this, we substitute this into here. Okay, intersect. So the equation right now will be, okay, we substitute these two. Let's call this equation 1 and equation 2. Okay, we're gonna sub 1. This is to find point Q. Okay, point Q. Sub 1 into 2. Okay, this will become x minus 9 over 10 x plus 27 over 2 equals to 11. Okay, let's see what's the easiest way to do this question. Okay, I would multiply it by 10 because I want to get rid of all the denominator. Okay, so multiply by 10, this will become, okay, let's do the next step first. X minus 9 over 10, this will be 1 over 10x equals to 11 minus 27 over 2. 22 minus 27 will be minus 5. Is it minus 5? Okay, wait. 22 over 2 minus 27 over 2. Yeah. Okay. Minus 5 over 2. Then multiply it by 10. So here will become x equals to 25 minus 25. So lots and lots of mental calculation here. Okay, after we get x equals to minus 25, we're going to substitute into one of the equation. Okay, so sub x into equation 2. So minus 25 plus y equals to 11. Y 11 plus 25, which is 36. Okay, so we have here q is equals to minus 25, 36. Okay, let's go to the last part. Okay, we have to go back to the diagram here. Yeah, bring it here. Put it right in the middle. Okay, let's label here. Q is negative 25, 36. how do we find a reflection on here? Okay, we know that the length here to here is the same as here to here. If you all have done enough past year paper, you will know that that you don't have to use length formula because you got two unknowns right now. We want to find the r, the x, and y. So we can use okay, this is what I call a vector. Okay, you can calculate the number of x and y, meaning what is the distance from Q to P? Then it will be the same distance from P to R. Got it? Okay, so you see from negative 25 to 5, what's the distance? We can take P minus Q. Then 9 minus 36. Okay, basically we can find what is QP vector like this. So QP, okay, QP means you take P minus Q. 5 minus 25, 9 minus 36. It will be equals to 30 minus 27. Okay, so the movement is 30 to the right. Okay, this one 30 to the right, minus 27 down. It means here also will be 30 and 27. From P to R will be 30 minus 27. Okay, so point R, or we can say OR. Okay, OR will be 5 plus 30, then 9 minus 27. This will be 35 minus 18. Okay, don't write it as OR, we have to write it as point R. Point R is 35 minus 18. Okay, this type of question, very similar as the past year straight line graph question. Okay, straight line graph with differentiation. So it's equation of tangent and normal. Okay, two more questions. Let's quickly finish this up. Okay, next one, vectors. Question 11. In the diagram, OA is A, OB is B. Okay, let's write here. OA, here A, OB, here B. M is the midpoint of OB. Point N is such that ON is equals to 3NA. Okay, so the ratio here is 3. This is 1. The lines BN and AM intersect at the point X. BX is equals to lambda BN. MX is equals to mu MA. Find OX in terms of AB and mu. Okay, AB and mu. Where is OX? And then we want mu. Mu is from MA. Sorry, we want lambda. What am I saying? Okay, lambda. So from BN. So we need to have some sort of BX over here. Okay, so we want OX. We can take OB plus BX. Okay, OB plus BX because we want lambda to be in it. So can we find, let's find what is BX first. Okay, so BX is equals to BO plus ON. Okay, BO plus ON. BO is negative B. ON is 3 over 4 A. Sorry, there's a lambda here. This is BN. Did you write wrong already? Okay, BN. BO plus ON. Negative B plus 3 over 4A. Okay, normally we put the A first. Okay, just for standard practice. Then we want to find what is OX. OX will be OB plus BX. OX is OB plus BX. Okay, what is BX? OB plus lambda and BN. So B plus lambda 3 over 4A minus B. B plus 3 over 4 lambda A minus lambda B. Okay, we can join both the both the B together. So we can write it as 3 over 4 lambda A plus 1 minus lambda B. Okay, the next one. OX in terms of A, B, and mu. Okay, let's mu. Sorry, not mu, mu. Mu is from mx here. Mx is equals to mu ma. So mx mu ma. Okay, we want to find what is ma first. Ma is mo plus oa. Okay, mo plus oa, which is negative half b plus a. Let's write down this here first. Okay, ma is mo plus oa. Mo is negative half b plus a, or a minus half b. Okay, we want to find what is ox right now. Ox will be o. Okay, what's the next one? Mx, right? So we want om plus mx. Ox is om plus mx. Okay, om will be half b. Mx will be mu ma. Okay, mu ma. Yeah. Okay, wait. Let's change first. Om. So om half b plus mu a minus half b. Half b plus mu a minus 1 over 2 mu b. Mu a plus 1 over 2 minus 1 over 2 mu b. Okay, you just follow whatever expression that they give you. Then the last one, hence find the value of lambda and mu. Okay, so we equate both the OX with each other. Okay, from A and B, which will get 3 over 4 lambda A plus 1 minus lambda B equals to mu A plus 1 over 2 minus 1 over 2 mu B. Okay, we equate both of these together, A and A, B and B to each other. So A will be 3 over 4 lambda equals to mu. B, 1 minus lambda equals to 1 over 2 minus 1 over 2 mu. Okay, this is equation 1. Equation 2, sub 1 into 2. Okay, so here will be 1 minus lambda equals to 1 over 2 minus 1 over 2, 3 over 4 lambda. Okay, we can get here 1 minus half equals to lambda minus 3 over 8 lambda. 1 over 2 equals to 5 over 8 lambda. And here will be 8 over 5 times 1 over 2 equals to lambda. Lambda, 4 over 5. Okay, 4 over 5 here. Okay, then we're going to sub lambda equals to 4 over 5 into 1. So mu equals to 3 over 4 times 4 over 5, where mu is equals to 3 over 5. This 2 is the final answer. Okay, this is question 11. And let's go on to the last question. Okay, question 12. Okay, question 12 is differentiation and integration, but it's a reverse differentiation method. Okay, first one, find dy over dx. So we use product rule. U equals to x, v equals to e to the power of 3x plus 2, u prime is 1, v prime is 3e, 3x plus 2. Okay, using product rule, dy over dx will be x times 3e 3x plus 2 plus e to the power of 3x plus 2 times 1. Okay, you don't have to write this step. You want to write straight away, the answer also can. 3x plus 2 plus e to the power of 3x plus 2. Okay, hence, find integral of this. Okay, this is called a reverse differentiation method. They are not asking you to integrate from this value itself. They're asking you use from here. When we integrate, we go back to the question again. Okay, so we will start from here first. Why we use that is because part of this is here. So when we integrate 3x e to the power of 3x plus 2 plus e to the power of 3x plus 2, we'll go back to the question again. Okay, our level right now, we never learn how to integrate this one. Okay, like a product rule kind. Next time when you go to college, you will learn this. Okay, but for now, we won't be learning this. Okay, so now we only want x and 3 e3x plus 2, which is this part here. Okay, this part here. So any other things, we want to bring it all to the right-hand side. So how can we write it? We can write it as 3 integral of x e 3x plus 2 dx. Okay, this part here, we move it to the right-hand side. Okay, and it will be an integral. So here will become e 3x plus 2 minus integral e 3x plus 2 dx. Okay, this one we can integrate. So here will be e 3x plus 2. When we integrate e 3x plus 2, we will get 1 over 3 e 3x plus 2 plus c. Then we have one more 3 over on the left-hand side. We want to get rid of the 3. We divide the whole equation by 3. So this will be integral x e 3x plus 2 dx. It will be 1 over 3x e 3x plus 2 minus 1 over 9 e to the power of 3x plus 2. Okay, this c you don't need to write as 1 over 3c because we don't know what is c. C can be anything. So you just write it as c as usual. Okay, so we just write x plus c. This will be our final answer. Question 12, reverse integration. All right, so I think if you all have practiced enough, honestly, the question is about the same, okay, as the previous syllabus. I think this one is easier because you all are limited by to not use your calculator. So I think the type of question is much easier. It's just that you all have to calculate it very carefully. Right? Okay, when you all do your mental calculation, make sure you all double check, triple check it. Okay, so I'll send this to you all. This is it for this paper 1.